Hey again, it's Mr. Lum, and today we're going to be talking about how to use the water constant, Kw. So last time we figured out what is the water constant at 25 degrees, and if we remember, Kw at 25 degrees equals 1.00 times 10 to the minus 14. And that is a constant. That's always going to stay this number at 25 degrees. So what we want to see now is how is that going to change if we add some HCl into the mixture. So imagine we have, here's our auto ionization of water, which is we have water and some of it ionizes and forms H3O+, which is pretty much the same as H+, and OH-. Now, if we were to do a KEQ formula on this, or in other words Kw, we would find that it would equal this number here, 1.00 times 10 to the minus 14. Now, if we added or created a solution that was 1.0 molar hydrochloric acid, what would the concentration of OH be? So in other words, what we're doing is we're adding HCl and H2O, and since this is a strong acid, it's going to 100% ionize, and it's going to become H3O plus and Cl minus. Now, if you remember, kind of like in solubility chemistry, we have like a common ion effect here. So H3O plus is going to increase this one. So if this was, like our problem says, 1.0 molar, if this was 1.0 molar, well, it's going to be just a forward reaction, and that means that H3O plus is also going to be 1.0 molar. So this is going to be 1.0 molar, and this will be also 1.0 molar. Now, since these are the same, it's going to increase this concentration. This concentration is going to increase and force this reaction to shift left. So that means the H3O plus is going to increase and the OH minus is going to decrease, but the Kw is always going to remain the same. So if we remember, Kw equals the concentration of H3O plus times the concentration of OH minus. And we know that, let's start filling in some of these numbers here. Normally in pure water at 25 degrees, this is 1.00 times 10 to the minus 7, and OH minus is also 1.00 times 10 to the minus 7. But now we added some acid, so it increased the H3O plus. So this is 1.0 times 10 to the minus 14. It's a constant. And the H3O plus has now increased to 1.0 molarity. And so what is our concentration of OH minus? Well, by mathematics, our concentration of OH minus equals 1.00 times 10 to the minus 14. Okay, so this number is the concentration of OH minus, and that kind of makes sense too, because if you compare, remember what our definition of an acid is. The definition of an acid is H3O plus is just greater than the OH minus. H3O plus is 1.0 molar, and the OH minus is 1 times 10 to the minus 14. Okay, now let's take a look at if we just change some of these numbers around just a little bit. So instead of having 1.0 molar, instead of that, we change it to 0.1 molar. And you can start to see a nice easy trend. So again, Kw equals H3O plus times OH minus. At 25 degrees, this is 1.00 times 10 to the minus 14th equals, now our H3O plus is equal to our HCl. So this is 0.1 molar, and this is going to be 0.1 molar. Okay, and so therefore this is going to be 0.1 molar and ROH minus. Okay, so solve for OH minus, and we see that OH minus equals 1.00 molar. 1.00 times 10 to the minus 13th molar. Okay?